Hello, let me show you how to solve this tricky SAT math problem on mensuration of plane shapes. The question says, in the figure, a square is inscribed in a circle. If the area of the square is 36, what is the perimeter of the shaded region? And then we are given these options. The first thing we need to establish here is that the shaded region is a segment of the circle. And the formula for finding the perimeter of a segment is given by length of chord plus length of arc, this arc here. Now let's take them one by one. Let's first find the length of the chord. The chord happens to be one of the sides of the square. So what we need to do is find the length of the square. We are told that the area of the square is 36. Area of square is 36 square units. The formula for finding the area of a square is area equals length times length, or length squared. What that means is that length squared is equal to 36. And we take the square root of both sides to find the length. So the length is equal to square root of 36, which is 6. Now let's find the length of arc. We don't have much information to help us with that, but we can rely on established properties of both the square and the circle to help us find that. So the first thing we do is we draw the diagonal of the square. Now, because the square is inscribed in the circle, the diagonal of the square is also the diameter of the circle. So let's call this D and find its length. This triangle right here is a right-angled triangle. And so we can use Pythagoras theorem to obtain the side D. By Pythagoras theorem, D squared, the square on the hypotenuse of the right-angled triangle, will be the sum of the squares on the other side. So 6 squared plus 6 squared. So D squared equals 36 plus 36, which is 72. So D will be equal to square root of 72. So this is square root of 36 times 2. The square root of 36 is 6. The square root of 2 is just root 2. So the diameter is 6 root 2 units. Again, if we draw the second diagonal, we can fall back on the properties of the square to find the length of the arc we are looking for. One of those properties is that when the two diagonals of a square intersect each other, they form an angle 90 degrees at the point of intersection. Now, the length of the arc we are looking for is part of this sector of the circle, and that sector subtends the angle 90 degrees at the center of the circle. And what does that tell us? Don't forget, the diagonals are also diameters of the circle. One diameter divides a circle into two equal parts, and so two diameters intersecting each other at 90 degrees will divide the circle into 4 equal parts. That is easy to understand. The sum of angles at the point is 360 degrees. 360 degrees divided by 4 is 90. The two diameters also divide the circumference of the circle into 4 equal parts. It means that the length of the arc we are looking for is 1/4 of the entire circumference of the circle. So length of arc is equal to 1/4 of the circumference, which is given by the formula pi times diameter. That means that the length of arc is equal to 1/4 times pi times 6 root 2. 2 here will be 2. 2 into 6 will be 3, meaning that the length of arc is 3 root 2 pi divided by 2. Now we can bring it all together. Perimeter of segment will be length of chord 6 plus 3 root 2 over 2 pi. Looking at the options, it's clear that option A is the correct answer. Like, share for others to get to see, comment under the video, but most importantly, subscribe to my YouTube channel at SAT Math with Sam for more. Thank you.